Okay, in this video is video 2 in chapter 1, lesson 4, solving inequalities. And we're going to look at compound inequalities. We're going to separate this into two videos because there's two types of compound inequalities. And then we'll do a final video where we look at an application of compound inequalities. So as I said, there's two types of compound inequalities. There are what we call AND inequalities, and this involves the word AND. Nice. And we have compound inequalities that are called OR inequalities, and I'll cover those in the next video. So we're going to look at AND inequalities, and there's a few things that we want to know about AND inequalities. Remember, an inequality, we're talking about something that's greater than or something that's less than. Okay, so we're looking at greater than or less than type inequalities. And we have three characteristics or some definitions of the word AND that we need to look at when we're looking at this. First thing is, one way that I can recognize what an AND inequality is it has the word AND in it. So I can say that x is greater than 4 and x is less than 12. Okay, so I see the word AND, thus we have an AND inequality. Now there is a second way to look at AND inequalities, or a second way that you'll see them, and that is when you have the x's in the middle and you have the same thing, it's greater than 4 and less than 12. So this would be another way that you could see an AND inequality. So sometimes you'll see the word AND written right in there for you, and sometimes you'll see it written like this. So whenever you see this, what you ought to think in your mind is AND. Okay, so that's what an AND inequality looks like. Those are the two ways that it can appear when you're looking at it in your book or exercise. Now, what does the word AND mean? In mathematics, it's very important that we define things. So the word AND, what that means is the value that I choose for x is greater than 4 and less than 12, it must satisfy both statements at the same time. Okay, so the number or the value that I choose for x has to make this inequality true and this inequality true at the same time. I can't choose two different numbers. I have to choose one number, and it has to make both of those true. That's a characteristic of the word AND. That's what it means in math. Both things must be true at the same time. Graphically speaking, if we're thinking about what it looks like graphically, the word AND is the intersection of the two inequalities. Okay, and so let's take a look at that. So this will give us a picture of what the AND inequality should look like when we graph it. So let's go ahead and graph this AND inequality. I have an inequality that x is greater than 4. So if I was to graph that, put my 4 here, it's greater than 4, that's not included, so greater than would be up to the right there. And then I look at x, that's this one now, x is also less than 12. So if I put 12 here, and I put this here, and I put less than, that would be these this way. Well, where are the numbers that satisfies both of these at the same time? Well, it's going to be the intersection. It's going to be right in here where the lines intersect, where they intersect or overlap. So my answer, graphically, would look like this. A number line, and I'm looking for the numbers that are greater than 4, so that would be here, and less than 12 here, and so the intersection of those two is in between here and here. So this is what the graphical answer should look like. And most, not always, but most of the time, your graphs of AND inequalities are going to look just like this. They're going to look like something in between two values. So your AND inequalities, a lot of them, most of them, 99% of the time, are going to look exactly like this, okay, because it's the intersection. So go ahead, we're going to go ahead and take a look at one example, and then I want you to do a couple in your book. Okay, so let me write this one example. So we have 3x minus 1 is greater than negative 28, and 2x plus 7 is less than 19. So I'm looking for the x values that satisfies both of these at the same time because it's an AND. So to do that, I simply
solve each one of these separately. So I'm going to add 1 to both sides. So 3x is greater than negative 27. I'm then going to divide by 3. So x is going to be greater than negative 9. Now notice I didn't reverse that because I'm not dividing by negative. I'm just dividing into negative. So I solve this one. I've got 2x less than 12. So x is less than 6. Okay, so there's my solutions. Now let me graph those graphically. So if I graph this, first one here, x is greater than negative 9. So I'll put my 0 on here. Negative 9 would be 9, greater than, not included, so it's an open circle. Greater than would be numbers up this way. Then if I graph the other inequality, x is less than 6, 6 would be here, open circle. It's going to go this way. So where do the lines overlap or intersect? Right in here. So my answer, and again, I want your answer to be separate. Then you may use this to kind of help you see what the answer is, but I want your answer to be shown separately. So I'm going to put 0 here. I'm going to put 6 here with an open circle. I'm going to put negative 9 here with an open circle, and it's the numbers in between. And so this would be the graphical representation of my answers of this inequality. Okay, so right now I'd like you to go ahead and stop the video, and in your lesson I want you to go ahead and do number 18 and number 21, and when you come back I'll have those answers for you, and then you can take a look at those. Okay, so go ahead and do that right now and make sure you understand this.
Okay, so here we have number 18. So we solve this inequality. We get x greater than negative 5, so negative 5 greater than would be up this way. X less than 2 would be this way. The intersection ends up being between any number between negative 5 and 2. Okay. Number 21, we solve that. We have divide by 7. We get x greater than negative 5, so that's the numbers to the right of negative 5 on your number line. And then less than 6, so it ends up between. Notice that our inequality, graph looks exactly like it should. Okay.